examples I have written over here. Here examples are sound waves, waves produced in water, waves produced in rope, etc. Now I quickly go to types of mechanical waves. Electromagnetic waves do not have further types, but mechanical waves have further two types. Number one, longitudinal or compressional waves, and the second type is transverse waves. You just consider this example over here. When you move the rope upward and downward, this is the direction with the arrowheads I have mentioned over here, and this wave is produced. When this wave will move like this one, overall the direction of the wave is like this one, whereas disturbance was up and down. So angle which is going to obtain over here is 90-degree angle. So we may call it in transverse waves particles of the medium. These are the particles of the medium. Particles of the medium vibrate perpendicular to the direction of wave. Wave is moving like this one, and particles will vibrate upward and downward. Wave is moving forward. So particles of the medium vibrate perpendicular to the direction of wave. Examples of transverse waves like this one: waves produced on water surface, waves produced in a rope, etc. These are transverse waves. Now remember this portion, this is the mean position. All the particles which are above the mean position, we call them crest. We call them crest. And all the particles which are, these are the particles which are below this mean position, we call them troughs. So remember, transverse waves travel in the form of crests and troughs. Now coming to longitudinal or compressional waves. Compressional waves are longitudinal waves. In these waves, particles of the medium vibrate. Here I said perpendicular. Here particles of the medium vibrate parallel to the direction of waves. For example, if wind is if wind is blowing in one direction, sound waves will also travel in that direction. So sound waves and particles of medium or air are parallel to each other. So sound waves are longitudinal or compressional waves. So look at almost the same definition. The difference is about the word perpendicular and parallel. Okay, here these are the regions where particles are compressed. If you open the door of your room, the air in front of the door will be compressed. That portion is known as compressions. That layer of air, the particles of air will relax and gap will be generated. We call them rarefaction, and pressure will be exerted to the next layer. That particles of the air will be compressed, and when they will relax, the pressure will go to the next one, and in this way the sound wave will travel. We call them longitudinal or compressional waves travel in the form of compressions and rarefactions. So this is all about, you have to write the definition, then you have to give the example, and then you have to tell that longitudinal waves travel in the form of compression and rarefaction. In the end, compressions are the region where particles of the mediums are close together, are compressed, and rarefactions are the region where particles of the medium are spaced apart. Thank you very much.